Awesome. Hey, y'all. So kind of parroting Rails here. I called this talk Ruby on Rhoda. I also like the double R there. So kind of the goal here is to kind of introduce you to Rhoda. I'm not going to go super in depth about all the particulars about how it works, why it works the way it works. The creator of Rhoda already did that. He did a really great job of it at RubyConf in 2014. I included a link to that presentation. It's about 30 minutes. So if you want to know a little bit more of the details about how Rhoda works on a little bit lower scale, please check that out. My name's Justin Burris. I'm currently the Director of Engineering at Ground Floor. We're like a crowdfunding real estate investment company. And right now we use Rhoda to kind of help us build out our API. And so I think you can too. But also interesting about Rhoda is that you could theoretically replace Rails with it. So we'll go into that in a minute. So what is Rhoda? It's a really lightweight framework written in Ruby. There's this other framework called Cuba that kind of inspired Jeremy Evans to write Rhoda, and I included a link to that. You can see he's made quite a few changes, 940 commits ahead. So one of the things that Jeremy Evans kind of like was inspired by in Cuba is this concept of a routing tree. And then he took that concept and he just kind of blew out a whole bunch of stuff that he'd always wanted in a framework. So Rhoda has this routing tree concept, which I'll go a little bit more into details later. It has this concept of extensibility via plugins. And it's very lightweight and very little global namespace pollution. So one of the things that you'll kind of see with a lot of these frameworks that exist out there already is that they add a whole bunch of stuff into whatever your current request context is. Whether it's Rails or Sinatra or whatever, there's a whole bunch of hidden variables that get mixed into what you're working on that unless you're aware of, you can actually cause some really big problems in your application. One of the nice things about Rhoda is that it introduces a very small number of kind of global variables into your namespace, as small as 8. So it's pretty lightweight, both in the pollution. In terms of plugins, you can overwrite pretty much anything about the framework, which is really neat too. So if you want to overwrite the way Rhoda handles requests or the way it handles responses, you can do that, and it's baked into the framework. So that's really neat too. So, a pretty natural question is, okay, you have this cool little micro framework, but when would I want to use it instead of Rails? So Rails has a whole doctrine around it. It has this concept of Rails being omakase. And the whole idea here is that, the people at 37 Signals knows what's best in terms of what should go into Rails, and they bake it all in. And additionally, there's all these concepts about convention over configuration, which have a lot of really great benefits in terms of, getting people up to speed much more quickly because they can just take one thing from an application to another. There's some drawbacks to that as well that I'm not really going to go into detail about, but Rhoda is definitely not this at all. So with Rhoda, you can kind of like craft your framework to suit whatever your needs are. Some people are really attracted to this. I personally am. This allows you to have a lot more freedom about how you handle requests and how you handle responses, different ways you can implement authentication. You don't have to say, man, I don't want to use Active Record, I actually want to use SQL. You can just pick to use one or the other at the time you start working on your app. Or maybe even some other more esoteric tools and stuff that fit your particular need. You can abuse this freedom, of course, because as soon as you start mixing and matching different tools together, you have to be pretty careful about what you're bringing in. So you have to be careful. I was going to put a performance slide on here with a little cool graph, but I wasn't able to generate it. But basically, one of the really cool things about Rhoda and the way it's set up is that it can handle a boatload of routes. I mean 10,000 routes and serve requests in under 5 seconds. As a comparison, the graphs I was looking at, Rails was sitting around 50 seconds to handle that many routes. And then Sinatra was also pretty bad too for that. So I was trying to generate the graphs, but unfortunately it requires a lot of computing power, and this little MacBook Pro couldn't do it in time. But I encourage you to check it out. Jeremy Evans has a repository called R10K, where he generates 10, 100,000, 10,000 routes, and he shows the performance for different frameworks of your choice. So if you do have an application with a whole bunch of routes in it, you can use Rota to handle them very quickly. One of the things, too, that's really cool about Rota that I'll go into a little bit of detail in later is that it has this concept called multi-routers. And with the multi-router, you can actually take your application's routes, split them across multiple kind of like sub web application frameworks, and then you can just route to them based upon whatever your request is. So from a very high-level viewpoint, let's say you have an API with 100 different routes, and you want to version it because you want to support different people's requests and different people's features. You can then have multi-routes for each different version of your API, and you don't have to worry about that slowing down the overall performance of your application. So speaking of multi-routes, in terms of microservices, Rota's really great for this. You can embed Rota, since it's just a Rack app, in anything that supports Rack. So if you have a Rails application and you want to add Rota into it to just kind of test it out, boom, you just pop it in and you can use it. And so you can get running on Rota very quick. And since it's so lightweight, you don't have to worry about it necessarily really kind of complicating your application structure in terms of the gems it requires. In fact, it only requires one gem, and that's Rack. So you're already using that if you're using Rails or Sinatra anyway. So that's really nice. And then, like I mentioned, since it is extensible via plugins, you can take all the current stuff that you use in Rails or Sinatra or whatever and just mix it in with your Rota setup. So, speaking of Sinatra, when would you want to use it instead of Sinatra? Sounds like it solves a lot of the same problems. And in fact, there's a lot of similarities. Both of these systems express routes directly. So basically, instead of having a route file, you'll say like get or post, and then you'll have a block that describes what happens when that request is processed. And then both kind of combine this like route controller and view responses on that same block. So they both kind of provide a lot of the similar behaviors there. But let's kind of compare and contrast a Rota app versus a Sinatra app. And I think you'll start to see where some of the benefits begin to emerge. So with this really basic Sinatra app that I borrowed from Jeremy Evans' website, you can see here we have some basic routes where you're doing some GET requests, some post requests, and deletes. And with each of these, you're kind of instantiating different instance variables, checking access, and then returning some kind of response. So there's a lot of duplication in this. Rails would recommend that you solve this by setting up like a before action. You could probably do something similar where you just define a method and then call that method. But it's not really built into the framework, in Sinatra in particular. So let's kind of compare this to Rota real quick. So here with Rota, you'll see we start with this very high-level route at the very top. And then what Rota does is says, OK, if you have an artist on your path, then we're going to process everything inside of this block and then perform separate matchers on each element remaining in the request. So when you make a post request to /artist on your web server, Rota will read /artist, pop it off of the queue, and then process the post request. And so you'll see here at the very beginning of the request, it sets the instance variable, the block. It sets the instance variable. It checks access. These methods here, this get, post, and delete, can leverage the values set in this block, and they can leverage the fact that you've checked access in this block. So for example, if a user comes in and the check access check fails, then none of these Rota responses will process. So here you've kind of completely abstracted out all this concept of, OK, have I checked that they've logged in, that they have the right resource, and et cetera. It's all kind of done for you in the structure of the route. And this is really powerful. And you can leverage this throughout your entire routing application to do much more than just access and authorization. So here are the two combined, kind of like side by side. You'll see that you actually have a little bit more code in the Rota app versus the Sinatra app. But I think you can see how it could theoretically scale a little more easily than your Sinatra app. So plugins. Oops. So this is where I was going to click on this link here. So Rota has a whole bunch of really cool plugins kind of shipped with Rota itself around all sorts of different things that you can do. Amusingly, out of the box, it only supports Git and Post. So if you want delete or patch or put, you got to use this all verbs plugin. And then there's a whole bunch of other stuff around error handling, multi-route, like I mentioned, which is a really powerful plugin. There's some rendering for the view. So, I mean, there is a ton of these plugins. And then you can also write your own, of course. Sweet. So that's a whole bunch of stuff about like some theoretical uses of Rota, but we've been using Rota at Ground Floor for about 2 years now. And so I wanted to show you like what this stuff kind of looks like in production. And this is where my talk differs a little bit from Jeremy Evans' talk. And so you can kind of leverage the two if you'd like. So here you can see a really basic file that represents our web server. And this is basically the entry point for our Rota application. And we have some required files here that like are things that we use in terms of middleware and et cetera, because it's just a rack app. And then these requires here from 10 to 17 kind of represent other Rota apps that we're going to load and run inside of our file. So here you see our entire Rota server from the very first entry point is really simple. All it does is say, OK, use some of these plugins, which will now be used in every application that the server runs. And then down here, you'll see from 30 to 39, 33 to 39, these are all the different applications that we run in this server. So every single one of these applications will be loaded up, and when we receive a web request, these will process whatever the response or the request is. By the way, if you have any questions at any time, feel free to ask. So here's an example of one of these multi-route files. So here you see I have server run v0 at v0. So this is the versioning of our API that I mentioned earlier. And inside of this, you'll see we've declared it as a JSON API app. This is just another kind of like wrapper we've put on top of the existing Rota infrastructure that requires a lot of the things that we need in order to do the things we need to do. We got some Warden authentication strategies here where we talk about, hey, we want to use a JWT. If there's an error, go ahead and use this error application. And then require all these different routes that actually process requests. So when a request comes into our application that matches this v0 accounts route, we'll route it to the appropriate file. So here, for example, I've shown you one of these files. We have investor updates. You see we do a Warden authentication at the very top. So you have to be authenticated to access anything in this file that's inside of this block. And then we have the kind of similar, so in his example, he had is. On is very similar. You can watch his talk to figure out all the differences between those two. But here you can see that we fetch a file from a database using a SQL model. We then authorize the request against that object to make sure the user can actually perform the action. And then we serialize it using a serializer we wrote. And then similar here, if we have a patch request, we just make a call to an interactor with some details about the response, and then we serialize. And then if there's a failure, we process it. So one of the things that I want to point out is that all of these things we picked to use. So you could change out any of this stuff at any time if you so desire to suit your particular needs for whatever your application is. Maybe you don't need to serialize. Maybe you need to do something else, like send a happy face or something when you get a request. So, one of the things is I've been showing you a whole bunch of stuff about HTTP requests. there's actually some other really cool ways to leverage Rota. So in here, this is an example of another Rota app that handles HTTP requests. It's just, this is our Mandrill subscription app. And here you'll see we're using some middleware and additionally a failure app that we've declared, this inauthentic Mandrill webhook. And basically whenever this route processes and there's a failure, we're going to go ahead and call this inauthentic Mandrill webhook. And all it is another Rota app that doesn't have any matchers. And so we're able to leverage the Rota framework to route this response, theoretically. So we could route on, for example, values in the error message to have custom error handling. Additionally, beyond just like a regular HTTP request, one of the things that we have to deal with a lot when programming is event handling, in particular in our application. So let me kind of show you the event handler that I whipped together in like 10 minutes that turned out to be a giant disaster, and then how we refactored it. So it's not letting me drag over the, it's because it's full screen. There we go. Oh man, that brightness is bad. Let's see if I can make it a little better. Files, colors. Okay, there we go. Oh yeah, definitely. Okay, so when we first needed to handle events in our API, basically whenever we have a state change in our application, we fire an event, and then we let different other applications process that event as needed. You'll see here, these are some event types. We have some of the different transitions that we care about, and this is an enormous file, the whole bunch of these things. I mean, just so many. And then finally, we get to this enormous case statement that just says, okay, what type of event is this? Let's go ahead and then call the right method that processes that event. And then each of these methods then say, okay, is the event included rather in these events that I care about? So this is nasty. I mean, this file is so big. You don't want to have this happen to you. Don't let it happen. But Rota actually helps out with this problem. And it's really cool how it does it. So just like you can handle HTTP requests, you can handle pretty much anything with Rota. So we created this new event processor that's just a Rota app called Events, and we call it with a payload. And this is basically what this class looks like. I've kind of truncated some things out to make it screen readable. But here you see it's an event. This events class inherits from Rota. We take whatever our event is. We then parse some details out of it. And then based upon some things that we care about in the event, this is similar to those constants I had at the very top of the file. We then route to the appropriate Rota application to process it. So here you'll see we have this, okay, hey, Justin, wrote this terrible event handler. So until we refactor it out, let's go ahead and still make sure we process it. So I can still leverage the old event handler without having to have all this tricky code that says, hey, did we process this event? If not, then use this. Rota just does it for you, which is awesome. So here, just like we did with the other HTTP routes, we then require all these different event classes. And then here, you can see one of the event routes where when we have a request come in, and the event matches the rota, we're using rota again to detect whether or not it matches. We then process the event. And so here we're leveraging the whole framework to basically handle these giant case statements, to handle all this equality between like making sure we're in the right event, and it's super easy to kind of understand. You can just say like, okay, we have an address event, it's in this, little hash that we care about, so go ahead and do whatever we need to do for that. So that makes our life a lot easier. So, in summary, you should consider rethinking your routing structure. For a long time, I hadn't really thought about, Rails routes because they work, but they actually kind of could be so much more. And considering you can just embed Rota into your Rails application and try it out really easily, it makes micro applications really easy to build in ways that you maybe haven't thought about before. And then finally, you can process more than just HTTP with this thing. And so that's really neat too when you start thinking about all these different complex logic paths that you may have in your application, and how, depending upon a request structure that you could build, so I'm kind of thinking something like Graphite and how you build all these Graphite strings, you can now then route to the appropriate location just based upon a hierarchy. So I also included in this talk a whole bunch of resources if you're interested in learning Rota. This first one is just a link to Jeremy's page for Rota, and then the GitHub repo. I also included his recommended entry point to like, hey, what is Rota? How do I use it? How do I leverage it? This is a book that's been written about Rota. This is his talk that I mentioned earlier. And then these are the list of plugins that you can access. And then if you want to performance test Rota, this is a link to that repository. So if you're interested in working with Rota and you want to learn more about it, we're hiring. So you can feel free to talk with me about your application, a little bit more in depth about some of the other things we're doing with Rota after this talk. Otherwise, thank you.
So maybe answer this, but so Sinatra is also very lightweight.
Mm-hmm.
So at what point do I say, well, I would have done this in Sinatra, but it's just too heavy and slow. I need Rota.
Yeah, so one of the things to keep in mind is there's kind of a paradigm shift in terms of how you think about your microservice. I mentioned that Rota is lightweight in the same way that Sinatra is lightweight. It's actually even lighter weight. It's like a megabyte less, which, woo, exciting. But also the namespace pollution. I think in Jeremy Evans' talk, he mentions that Rota has like 8 values it adds to the namespace, whereas something like Sinatra adds like 60. So that's now 60 things that you have to maybe consider when you're writing your application. Additionally, you can't override a lot of the way that Sinatra works in the same way that you can override things in Rota with its plugin infrastructure. So as an example, let's say you want to change up the way Rota processes some of these requests. You can totally insert your own stuff into that request method that you care about, and then you can call super and then still get access to the original code. Or you could just completely ignore whatever Jeremy Evans wrote entirely and use your own thing. Finally, if you have a boatload of routes, that's where the routing tree can become really powerful for you. And so you can get a lot more throughput for your requests than you can with Sinatra. And his graphs are like hella convincing. I just didn't want to include them because they're like 4 years old. And I'm sure things have changed, and I didn't want to like show you all a whole bunch of bad data. And then finally, being able to manipulate the request at any point in the request cycle can be really important for some people. Like if you want to make sure that every single request into your service has authentication, you can put that at the very beginning of your application structure, and you no longer have to worry about it at all in the rest of the app. So it's stuff like that that kind of gives you a lot of cool power that you don't just get with a standard kind of array-based routing structure.
I have a couple of specific questions. First couple example, if you go
Yeah, man.
there was an example of basic routing.
The Sinatra or the Rota one?
The first, yeah, this one.
Cool.
It says R is artist, comma, integer.
Mm-hmm.
Is it to
So your request would look,
I wonder how the process might be.
yeah, your request would look something like, let's see if I can get it to pop up. Darn. I don't know that that's going to be big enough.
I saw it, and I kind of get the artist from URL, right?
Yeah, so this is exactly. So what happens here is if you think of each value in your URL string as kind of an element in a queue. And what Rhoda does is it pops the very first item off of the queue, and then it processes that, and it says, okay, what route that we've defined in our file or our files matches this particular piece of the puzzle.
So if you have multiple values, let's say URL plus parameters, how to process it.
Yeah, the params get processed independently and just come in a params keyword.
Just for URL for the path.
That's right.
And if you have multiple values you want to extract, how do you do it?
Multiple values that you want to extract from the route.
/100/200.
Yeah.
You just have longer.
Oops. So here, all you have to do is you would just save those values as you go through, like he does here. So here you have like artist ID. You could have theoretically another level beneath this. Let's say it's called album, and then you could have like album, R is album, comma integer, do album ID, and then you could set that as an instance variable, and then everything inside that block would have access to this @artist. And I think the artist ID as well.
And another one, later in one of the examples, you had freeze, but that's two places. Back was the top of the page, that was organization structure.
Let's see.
Yeah, almost the latest piece of code you showed. There was constantly made, I think. That was quite interesting. Yeah, this one.
Oh, yeah.
You freeze inside hash and also freeze
Mhm.
array. What's the difference if you just freeze outer array?
Yeah, so if you freeze the outer array, you can actually change the elements inside the hash.
So it's freezes only the outer thing. and
That's right.
still only copy.
Yep. Another thing that's kind of cool about Rhoda that we're actually not leveraging is that you can freeze this routing structure. And so in production, when you're running this thing, you can set it to where it can't be modified. So if you want to make sure like your routes are like what your routes are, you can know that, which is kind of cool. Any other questions?
So what was the origin of these events, the event examples? Like how did those
Ah.
arrive at your system?
Yeah, so I'll dive a little bit deeper into that. So whenever we have a state transition on an object, or we haven't built this out fully yet, but we're working on it, or we have data that gets updated that we care about, we have some metaprogramming that will emit an event on either a Redis notification bus or an AWS notification bus. Depends on if we're in production or on our local machines. So we receive requests. We receive kind of like webhooks from AWS that says, hey, there's a new event that happened. And our Rhoda app then processes that and then puts it into our own internal event bus that processes the request from AWS, puts it into a format that our events expect to be in, and then they get routed into this event system. So we deal with loan applications and investments. And so as an example, when someone purchases an investment in a loan, we fire an event for that. And then we have different code in our system that listens for those events. Same thing goes for if they cancel an investment.
I think what interested me about that was that when you, towards the beginning of the talk, you were saying, can handle 10,000 routes.
Oh, yeah.
I was thinking to myself, like, when have I had seen an app with 10,000 routes? Exactly. And like that's more than I think a team would have a lot of difficulty comprehending.
Yeah.
10,000 routes.
Yeah.
Yeah, and so like this seems like a kind of like you can sort of use this not only for routing web addresses or paths, but also whatever you want.
Exactly.
I guess. Like
Exactly.
Sort of global routing for anything that might happen in your app.
Yep.
That's interesting.
And yeah, and I didn't do such a great job talking about that, but that's kind of the power of, like, when you start thinking about so many routes, it's not just HTTP.
Yeah, right, so, yeah, multi-purpose.
Yeah.
Quick question, so how do you do like RSpec or other types
Mm.
of authentication, like Cucumber or whatever?
Yeah. Yeah.
Is this function? I mean, I see you combine the routes and the controller and possibly everything kind of like compacted.
Yeah.
Is it easy to test or not?
Yeah, so it's actually really easy to test. And the reason why is that I kind of alluded to this, but I didn't dig into it. Let's go to here. So here you'll see we have this line 20. We have resource, update call, blah, 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 resource name, investor updates. So this is a very generic example, but we use an interactor pattern to handle all of our business logic. And what you can do is you can take these interactors and you can spin them up in any test environment. You don't have to be in an HTTP request. You pass them these params here, client, params, resource, whatever you want, and then you can test the response from those. So here you'll see we have like result success, result failure. So you can load that up into RSpec too. So this is just like a very high level view. Let's see. I can show you a real world example of an interactor that will kind of maybe help to illuminate what I'm talking about. Cool. So here you can see we have a whole bunch of interactors that do a whole bunch of different stuff. We believe in a flat directory structure, as you can tell. So let me pull up the purchase investment. Yeah, so anytime we want to purchase an investment, we have an interactor that's actually an organizer that organizes multiple interactors together. And then each of these interactors will run one after another to do some kind of manipulation to the context of the interactor. There's just a Ruby gem called Interactors that does this for us. It's from Collective Idea. So if I go into this file, my C tags are broke. Here we go. Here you can see there's a call method, and there's this concept of a context. And depending upon what happens during the call method, you might add like errors to the context, or you might add other objects. And so each of these files, each of these interactors has a unit spec that makes sure that whatever we expect for it to do, it does. And then each of the requests that come through and call one of these organizers has a request spec that then tests to make sure that for a given set of inputs, we have the expected outputs. That all tends to work out pretty well. And it's actually pretty easy to test. I'll show you some tests. Oops. Got a little typo there. Yeah, let's look at this one. So here, you'll see I set up some data that I'm going to use to test against. I create a user, and then here's my context, where I go ahead and call my interactor with my params, just like I do in a Rota app, and then I test the responses. Cool. Does that answer your question? Excellent. Anything else? All right. Well, thank you all so much. If you'd like to talk more about this, let me know. I'd love to chat about it.